Transformations of linear functions. So transforming a linear function means to change it either by shifting it up or down or by making it steeper or less steep. And we're going to do this by adjusting the slope and the y-intercept of each of our linear functions. So let's look at an example. So we want to shift the linear function y equals 2x minus 1 up by 5. Okay? So if I want to shift a linear function up by 5, if this is my linear function here, I want to be shifting this entire line up by a factor of 5. Okay, so if I'm shifting it up by 5, then wherever my y-intercept is, it should move up by exactly 5 points. So essentially, all of the points on my line are going to move up by 5. Okay, so if my new y-intercept was up here at 4 instead of -1, because -1 plus 5 would be 4, okay, I can keep everything else about my line the same. So my line slope is 2, so I could still have a slope of 2. Use that to graph my new line. And then add in my nice straight line. Oop, not black. We want our purple. So as you can see, the slope of the line or the steepness of the line is the same. The only thing that I shifted up is the y-intercept, or essentially I shifted all of the points up. The y-intercept is just the easiest one to understand. Okay, so my new function now, it's still a slope of 2, but now my y-intercept is 4. So y is equal to 2x plus 4. So I want you to note the difference between the two functions. Okay, my original function had a y-intercept of 1. My new function has a y-intercept of 4, but the slope stayed the same. Okay, so the only thing that changed is the y-intercept when I shifted my function up. Okay. For number 2, we want to shift the function y equals 1/3 x plus 4 down by 2. So if shifting up meant we added to all the points in our graph, but the easiest one to work with is y-intercept, then shifting down makes sense that we're going to subtract. Okay, so if I want to subtract by a factor of 2, my y-intercept here is 4, so my new y-intercept would be 2. Okay, and then I would still follow my same slope, so down 1 to the right by 3, down 1 to the right by 3, down 1 to the right by 3, and vice versa in the opposite direction. And then I can add in my line. Okay, so it looks pretty similar, but we can pretty clearly see that our function is shifted down by a factor of 2. Okay, so it's essentially shifted straight down by a factor of 2. Our slope has not changed. Our slope has stayed the same. Only our y-intercept has changed. So our new equation should still be y equals 1/3 x. Okay, but shifted down by 2. So now, plus 2. Okay, so moving on from here, number 3, okay, we want to make the function y equals 3x minus 2 steeper. Okay, so the steepness of the graph refers to the slope. And think about it, if a hill was steeper, then it would be higher up, it would be harder to get up, okay? So that just means it's going to climb at a higher rate or at a higher rate of change. Okay, so if I'm changing the steepness, I'm changing the slope. And I want to kind of give you a couple of examples of changing the steepness of the graph. Okay, so my first example is we're going to change it from y equals 3x minus 2 to y equals 4x minus 2. Okay, so I want you to notice, so same exact y-intercept, we're still at -2, but now my slope is 4/1. So I would go up by 4/1. And down by 4, to the left by 1. Oop, I didn't go enough on that first point. And so then we'd add in our line. Okay, and it might be a little hard to tell, but our function is just a tad bit steeper. It does now rise by 4 and run by 1 instead of rising by 3 and run by 1. So it does get a little bit higher, a little bit faster. Let's go significantly higher. So let's do y is equal to 6x minus 2. So still same exact y-intercept, but now we're going up by 6 and over by 1. Okay, and you should notice, once again, my function has gone just a little bit steeper. Okay, and we can get even steeper than that, so let's do it one more time. Let's do y is equal to 8x minus 2. Okay, so if I do 8x minus 2, still same exact y-intercept, but now I'm going up by 8 and over by 1, down by 8 and over by 1. So notice once again, just a little bit steeper. Okay, so what you should see is that as my slope becomes a higher whole number, okay, it becomes steeper. And the same would be true if we were going in the negative direction. So say we had negative 3x, we'd make it steeper by going from negative 3x to negative 4x to negative 6x to negative 8x. Okay, so increasing the slope, making it a higher whole number, okay, essentially getting further away from 1, or further away from 1 is going to make it a steeper slope. Okay, so let's look at another example over on the back of our notes. So we want to make the function y equals negative 4x plus 3 less steep. Okay, so to make a function less steep, I want it to go from a very steep, in this case kind of like a hill like you're running it down it, to a more gradual, okay, almost as close as I can get to flat. Okay, so let's just go a little easier. And we'll go to, instead of getting bigger, so going from negative 4 to negative 6 or negative 4 to negative 8, okay, we're going to go closer to a value of 0. Okay, so let's do y is equal to negative x plus 3. Okay, so notice my slope has gotten, it's still negative, but I'm moving it closer to a slope of 0. Okay, so my slope is now negative 1x. So negative 1x plus 3, I would still go to 3. But now I'd go down 1 and to the right by 1. And I can do that all the way down and across. And all the way up in the other direction. And that would give me a nice little negative slope of 1 with a y-intercept of 3. Okay, so notice that's already, changing it from negative 4 to negative 1, a significantly less steep line. Okay, a little bit better of a hill to run down. You'd probably fall straight down the first line, but this one you just kind of roll down it pretty quickly. Okay, well, let's get a little closer to 0. And I'm not going to cross over to a positive slope. That's going to kind of flip it entirely from instead of a decreasing line to an increasing line, which isn't necessarily less steep. Okay, but let's get closer to 0. So the way I could get closer to 0 is by making my slope into a fraction. So I could change it from negative 1x to y is equal to negative 1 over 4x plus 3. Okay, so if I do that, still going to go through my y-intercept of 3, but now I'm going down 1 and to the right by 4, down 1 and to the right by 4, up 1 and to the left by 4, up 1 to the left by 4 in the other direction. And we get a nice little line. And add our arrows onto the end. So notice how it's already significantly steeper than our line of negative 1x plus 3, but it's significantly less steep than our original line of y equals negative 4x plus 3. So I'm getting closer to 0 without actually switching over, either equaling 0 or switching over and becoming a positive slope. So if I wanted to go even less steep, I could do y is equal to negative 1 over 8x plus 3. So that would still be y-intercept of 3, down 1 to the right by 8, up 1 to the left by 8. And as you can see, we get even less steep. Okay. So now let's kind of draw some conclusions about the different transformations we saw. Okay, so what do we notice about our transformations? So shifting up or down, if I want to shift up, then I'm going to add to the y-intercept. Okay, so if I want to shift my graph up, I'm going to add to my y-intercept. So my y-intercept is negative 2. So if b equals negative 2, and I want to shift up by 3, then my new b would be equal to 1. Okay, if I want to shift down from what we saw earlier, then I want to subtract to the y-intercept. So as an example, if my b is equal to 5 and I want to shift down by a factor of 2, then my new b would be equal to 3. Okay, so shifting up, I want to add to my y-intercept. Shifting down, I want to subtract from my y-intercept. Okay, making steeper slash less steep. Okay, so steeper I want to make my slope bigger. A bigger whole number, or another way to say that is further from 0. Okay, so as we saw with our slopes, and slope's kind of the hard one, okay, to make my slope steeper, I wanted it to be a larger whole number or a number further away from 0. So I started at 3, I increased to 4, it got a little steeper, I increased to 6, it got a little steeper, I increased to 8, it got even steeper. Okay, so making it a bigger whole number, okay, is going to make it steeper. Okay, if I want to make it less steep, I want to make slope a smaller number or closer to 0. Okay, so as we saw with our less steep, we went from negative 4 to negative 1 to negative 1/4 to negative 1/8, and we got significantly less steep each time. Okay, so the big thing though is that we do not want to change signs. Okay, do not change signs when making steeper or less steep. Okay, y'all, that is transformations of linear functions. I know they can, maybe be a little bit new in this idea, but we're going to work on them a little bit more in class.